Texas stands alone as the sole state in the United States that exempts the chemical and petrochemical industry from state electrical licensing and adherence to the National Electrical Code, commonly known as the NEC. This distinction, confirmed by the National Electrical Contractors Association, or NECA, sets Texas apart in its approach to electrical safety regulations within these specific industries. The reasons behind this unique exemption in Texas are multifaceted. Firstly, the petrochemical industry holds substantial economic significance for the state, contributing significantly to Texas's overall revenue. Secondly, proponents of the exemption, primarily within the industry itself, have argued that the existing NEC requirements are not adequately tailored to the specific and often complex needs of petrochemical facilities. They contend that strict adherence to standard NEC regulations can create barriers to innovation and operational efficiency within this sector. Thirdly, the exemptions were initially granted in 1991 and subsequently in 1999, predicated on the industry's commitment to self-regulation and self-enforcement of safety standards. This essentially placed the responsibility for ensuring electrical safety within these facilities on the companies themselves, rather than relying on external state oversight. However, this exemption is not without its detractors and has faced considerable criticism. Firstly, concerns have been raised regarding the potential compromise of safety and consumer protection. Critics argued that by exempting the chemical and petrochemical industry from state licensing requirements, there is a risk that electricians working within these facilities may not possess the same level of training, qualifications, and experience as their counterparts in other industries where state licensing is mandatory. Secondly, the NEC is a widely recognized and respected safety standard that has been developed and refined over many years. It is based on extensive research, testing, and practical experience, and it is designed to minimize the risk of electrical fires, accidents, and other hazards. Critics argued that abandoning NEC compliance in the chemical and petrochemical industry could lead to a higher incidence of electrical incidents, potentially endangering workers, the public, and the environment. As of December 2023, the debate surrounding the electrical exemption in Texas is ongoing and has intensified with the introduction of Senate Bill 1124 or SB 1124 in the Texas legislature. This bill proposes to expand the scope of the existing exemption to encompass commercial and residential electrical installations within certain chemical and petrochemical facilities. This proposed expansion has triggered significant opposition from various stakeholders, including electrical contractors, firefighters, and safety advocates who fear that it could further erode safety standards and increase the risk of electrical hazards. In conclusion, the exemption granted to the chemical and petrochemical industry in Texas from state electrical licensing and NEC compliance remains a unique case among U.S. states. While the exemption was initially justified based on the industry's commitment to self-regulation, concerns persist regarding its potential impact on safety and consumer protection. The ongoing debate in Texas, particularly surrounding the proposed expansion of the exemption, underscores the critical need to strike a balance between economic interests and the paramount importance of public safety. Understanding electrical licensing and the National Electrical Code, or NEC, requires delving into their purpose, scope, and significance. Electrical licensing serves as a mechanism to ensure that individuals performing electrical work possess the necessary knowledge, skills, and experience to do so safely and competently. Typically, state or local jurisdictions administer electrical licensing programs, which involve examinations, training requirements, and ongoing education to maintain licensure. The primary goal of electrical licensing is to protect the public from the hazard associated with faulty or substandard electrical installations. By requiring electricians to demonstrate their competence, licensing helps to minimize the risk of electrical fires, shocks, and other accidents. The National Electrical Code, or NEC, on the other hand, is a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment. It is developed and updated every 3 years by the National Fire Protection Association, or NFPA, a non-profit organization dedicated to fire prevention and electrical safety. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is widely adopted by state and local jurisdictions throughout the United States and serves as the basis for electrical inspections and enforcement. Compliance with the NEC is essential to ensure that electrical installations are safe, reliable, and meet minimum safety standards. Failure to comply with the NEC can result in fines, penalties, and even legal liability in the event of an electrical incident. Examining the arguments for and against exemptions for electrical licensing and NEC compliance is crucial for a comprehensive understanding. Proponents of exemptions, often industries or businesses seeking to reduce costs or streamline operations, argue that existing regulations are overly burdensome, unnecessary, or not well suited to the specific needs. They may also claim that they have internal safety programs and procedures that adequately address the risks associated with electrical work. Opponents of exemptions, typically safety advocates, electrical contractors, and labor organizations, contend that exemptions undermine safety and consumer protection. They argue that licensing and NEC compliance are essential to ensure that electrical work is performed safely and competently regardless of the industry or application. They also point out that exemptions can create a loophole that allows unqualified individuals to perform electrical work, potentially increasing the risk of accidents and injuries. The potential consequences of waiving electrical licensing and NEC compliance are significant. Firstly, there is an increased risk of electrical fires. Faulty wiring, overloaded circuits, and improper grounding can all lead to electrical fires, which can cause property damage, injuries, and even fatalities. Secondly, the risk of electrical shock and electrocution increases. Working with electricity can be dangerous, and unqualified individuals may not have the knowledge or skills to protect themselves from electrical shock. Thirdly, equipment damage and malfunctions can occur. Improper electrical installations can damage sensitive equipment, disrupt operations, and lead to costly repairs. Fourthly, there are code violations and legal liabilities. Failure to comply with electrical codes and regulations can result in fines, penalties, and legal liability in the event of an electrical incident. Several factors contribute to the debate surrounding electrical exemptions. Firstly, the economic considerations play a significant role. Industries seeking exemptions often argue that compliance with licensing and NEC requirements adds unnecessary costs and burdens to their operations. Secondly, the perceived level of risk is important. Some industries may argue that the risks associated with electrical work in their specific facilities are minimal, justifying an exemption. Thirdly, the availability of qualified personnel is a factor. Industries may argue that there is a shortage of licensed electricians in their area, making it difficult to comply with licensing requirements. Fourthly, the political influence of various stakeholders, including industry groups, labor unions, and safety advocates, can shape the debate and influence policy decisions. Weighing the economic benefits against safety risks when considering electrical exemptions is paramount. While cost savings and streamlined operations may be attractive to industries seeking exemptions, it is essential to carefully consider the potential impact on safety. A thorough risk assessment should be conducted to identify the potential hazards associated with electrical work in the specific industry or facility. The cost of implementing and maintaining appropriate safety measures should be compared to the potential costs of accidents, injuries, and property damage. Ultimately, the decision to grant an electrical exemption should be based on a comprehensive analysis of the risks and benefits, with public safety being the overriding priority. Examining the role of self-regulation versus independent oversight in ensuring electrical safety is also important. Some industries argue that they are capable of self-regulating and ensuring electrical safety through internal programs and procedures. However, critics argue that self-regulation can be ineffective without independent oversight and enforcement. Independent oversight, such as inspections by qualified electrical inspectors, helps to ensure that electrical work is performed in compliance with applicable codes and standards. It also provides a mechanism for identifying and correcting potential safety hazards. Understanding the legal and regulatory frameworks governing electrical work is necessary. Electrical work is typically regulated at the state or local level, with licensing requirements, inspection programs, and enforcement mechanisms in place. The NEC serves as a model code that is widely adopted by jurisdictions throughout the United States. Failure to comply with applicable laws and regulations can result in fines, penalties, and legal liability. Researching best practices for electrical safety in different industries provides valuable insight. Different industries may have unique electrical safety challenges and require tailored solutions. For example, the petrochemical industry may have specific requirements for electrical equipment in hazardous locations, while the healthcare industry may have strict requirements for patient safety. By studying best practices in different industries, organizations can learn from each other and improve their own electrical safety programs. Considering the impact of technological advancements on electrical safety is crucial. New technologies such as solar power, wind power, and electric vehicles are changing the landscape of electrical work. These technologies require specialized knowledge and skills, and it is important to ensure that electricians are properly trained and qualified to work with them safely. Additionally, new technologies can also improve electrical safety, such as arc flash detection systems and remote monitoring devices. Evaluating the effectiveness of current electrical safety measures is a continuous process. Organizations should regularly review their electrical safety programs, conduct audits and inspections, and track safety performance metrics. This information can be used to identify areas for improvement and to ensure that electrical safety measures are effective in protecting workers and the public. Keeping up to date with changes in electrical codes and standards is essential. The NEC is updated every 3 years, and it is important to stay informed of the latest changes. Additionally, state and local jurisdictions may have their own amendments and interpretations of the NEC. Organizations should subscribe to relevant industry publications, attend training courses, and participate in industry associations to stay up to date with the latest developments. Learning from past electrical accidents and incidents is critical. By studying past accidents and incidents, organizations can identify the root causes and implement measures to prevent similar events from occurring in the future. Accident investigations should be thorough and objective, and the findings should be shared with all relevant stakeholders. Promoting a culture of electrical safety within organizations is essential. Electrical safety should be a top priority, and all employees should be trained and empowered to identify and report potential hazards. Organizations should establish clear policies and procedures for electrical work, and they should provide adequate resources and support to ensure that electrical work is performed safely. Collaborating with industry experts and organizations is beneficial. There are many organizations and experts that can provide assistance with electrical safety, such as the NFPA, the Institute of Electrical and Electronics Engineers, or IEE, and electrical consulting firms. These organizations can provide training, resources, and technical expertise to help organizations improve their electrical safety programs. Engaging with regulatory authorities is necessary. Organizations should maintain open communication with regulatory authorities and cooperate with inspections and enforcement activities. By working collaboratively with regulators, organizations can ensure that they are in compliance with applicable laws and regulations and that they are contributing to a safe electrical environment. Advocating for strong electrical safety standards is important. Organizations should support efforts to strengthen electrical safety standards and to promote the adoption of the NEC and other relevant codes and standards. By advocating for strong standards, organizations can help to protect workers, the public, and the environment from the hazards associated with electricity. Ultimately, ensuring electrical safety is a shared responsibility. It requires the commitment and cooperation of individuals, organizations, and regulatory authorities. By working together, we can create a safer electrical environment for everyone. The significance of arc flash hazards and mitigation techniques requires special attention. An arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. It can produce intense heat, pressure waves, and molten metal, causing severe burns, injuries, and even fatalities. Arc flash hazards are common in many industries, including manufacturing, construction, and utilities. Mitigation techniques include using arc flash protective equipment such as clothing and face shields, implementing engineering controls such as arc flash relays and current limiting devices, and developing safe work practices such as de-energizing equipment before working on it. The importance of grounding and bonding in electrical systems cannot be overstated. Grounding and bonding are essential for protecting people and equipment from electrical shock and damage. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault current. Proper grounding and bonding can prevent electrical shock, reduce the risk of fire, and protect sensitive equipment from damage. The need for regular electrical inspections and maintenance is critical. Regular electrical inspections and maintenance are essential for identifying and correcting potential safety hazards before they lead to accidents or incidents. Inspections should be performed by qualified electrical inspectors, and maintenance should be performed by qualified electricians. Regular inspections and maintenance can help to prevent electrical fires, shocks, and equipment failures. The role of education and training in promoting electrical safety cannot be minimized. Education and training are essential for ensuring that workers have the knowledge and skills to perform electrical work safely. Training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. Education and training can help to prevent electrical accidents and injuries. The benefits of using qualified electrical contractors and electricians are substantial. Qualified electrical contractors and electricians have the knowledge, skills, and experience to perform electrical work safely and competently. They are familiar with applicable codes and standards, and they use proper tools and equipment. Using qualified electrical contractors and electricians can help to ensure that electrical work is performed safely and reliably. The importance of following lockout-tagout procedures cannot be stressed enough. Lockout-tagout procedures are essential for preventing accidental energization of equipment during maintenance or repair. These procedures involve isolating the equipment from its power source and applying locks and tags to prevent it from being accidentally turned on. Following lockout-tagout procedures can prevent serious injuries and fatalities. The benefits of using personal protective equipment, or PPE, for electrical work are crucial. Personal protective equipment, or PPE, such as gloves, eye protection, and arc flash clothing, is essential for protecting workers from electrical hazards. PPE should be selected based on the specific hazards present in the work environment, and it should be properly maintained and used. Using PPE can significantly reduce the risk of electrical injuries. The need for proper wiring and cable management is of great importance. Proper wiring and cable management are essential for preventing electrical hazards and ensuring the reliability of electrical systems. Wires and cables should be properly sized, insulated, and protected from damage. They should also be neatly organized and supported to prevent them from becoming a tripping hazard or a fire hazard. Proper wiring and cable management can improve the safety and reliability of electrical systems. The significance of surge protection for electrical equipment is extremely important. Surge protection devices, or SPDs, are essential for protecting sensitive electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power grid switching, and other events. SPD can divert surge current away from sensitive equipment, preventing damage and downtime. Using surge protection can save money and prevent disruptions to operations. The necessity of using ground fault circuit interrupters, or GFCIs, in wet locations is crucial for safety. Ground fault circuit interrupters, or GFCIs, are essential for protecting people from electrical shock in wet locations such as bathrooms, kitchens, and outdoor areas. GFCIs detect ground faults, which can occur when current leaks from a circuit to ground. When a ground fault is detected, the GFCI quickly trips the circuit, preventing electrical shock. Using GFCIs can save lives. The role of portable generator safety is often overlooked but of great significance. Portable generators can be a valuable source of power during emergencies, but they can also be dangerous if not used properly. Generators should be operated in well-ventilated areas to prevent carbon monoxide poisoning. They should also be properly grounded to prevent electrical shock. Following the manufacturer's instructions and taking appropriate safety precautions can prevent accidents and injuries. The importance of electrical safety around swimming pools and spas must be stressed heavily. Swimming pools and spas present unique electrical hazards due to the presence of water. Electrical equipment around pools and spas must be properly grounded and bonded to prevent electrical shock. Ground fault circuit interrupters, or GFCIs, are required for all electrical circuits serving pools and spas. Regular inspections and maintenance can help to ensure that electrical equipment around pools and spas is safe. The significance of electrical safety in healthcare facilities should be recognized for the high importance it possesses. Healthcare facilities have unique electrical safety requirements due to the presence of patients who may be particularly vulnerable to electrical shock. Electrical equipment in patient care areas must be properly grounded and protected by ground fault circuit interrupters, or GFCIs. Regular inspections and maintenance are essential for ensuring that electrical equipment in healthcare facilities is safe and reliable. The role of electrical safety in industrial environments should also be considered as of the utmost importance. Industrial environments often have harsh conditions, such as extreme temperatures, corrosive chemicals, and explosive atmospheres. Electrical equipment in industrial environments must be designed and installed to withstand these conditions. Regular inspections and maintenance are essential for ensuring that electrical equipment in industrial environments is safe and reliable. The benefits of using renewable energy sources safely are considerable. Renewable energy sources, such as solar power and wind power, are becoming increasingly popular. However, it is important to ensure that these systems are installed and operated safely. Electrical work associated with renewable energy systems should be performed by qualified electricians, and the system should be inspected regularly. Using renewable energy sources safely can reduce our reliance on fossil fuels and protect the environment. In conclusion, electrical safety is a multifaceted issue that requires the attention of individuals, organizations, and regulatory authorities. By understanding electrical hazards, implementing appropriate safety measures, and promoting a culture of electrical safety, we can create a safer electrical environment for everyone.